you guys need to have a homework assignment. And I think it's going to be related to, let's see, did we come up with it? Page 539, number 11. So let's take a look at that. Maybe I need to do that. Let's go take a look. I've got to get to the book. Yeah. What chapter? Does anybody know what chapter that one is? The homework list up. You know that? Chapter.
I think I have page 534. It's chapter, let me check. 8 I'm thinking 8.3.
8 point something? Okay.
8.3.
I don't think this is going to let us go to 8.3. It's the page number. It's kind of a messed up system. But I guess you all heard about the new vaccine results today by Medina. Man, that is great news. It means the people think, wow, it's 95% effective, which is amazing for a vaccine, by the way. But what is more amazing about it is its shelf life. You may not believe that that's important. And the storage of it. It doesn't have to be frozen like in the Arctic. It can be refrigerated for 30 days even. So not only is it more effective.
Oh, Professor Wickman, Gift is here.
Who is?
But I'm driving back home, so I might be in and out.
Is this Gift?
Yes.
Gotcha. I
Thank
got
you.
So let's look at number 11 here. Is this really the right one we got to do? Yeah, synthetic division, number 11. So I want you to do this problem in synthetic division. And
Professor, I'm not able to see it.
Pardon me?
We can't see it.
You can't see it.
Oh.
Well, let's see if we can get that to you again. Thank you for letting me know that.
Professor, can you hear me?
Yes. Who is it? Is someone talking to me? All right. Number 11. Can you see it now?
Yes.
Yes.
Okay, so here's the problem that is your homework. Now, what we need to do is come up with a due date. So what are you all thinking? Should we have it due by tomorrow, or when do you think you could have this done by reasonably and all that?
Just a couple of days, Professor.
What do you really think? I mean, I don't like students say, well, I missed class, now I know Wednesday.
Friday.
Friday?
How about Saturday, 10 o'clock p.m.?
Cool.
Yes.
That's even better.
Yes. Yes, that
Yes.
works.
So what is the date on that day? What would Saturday be then? Today's
I think it's the
16th.
21st. Yes, it's the 21st.
11/21. Okay, wait 1 second. Let me see if I can find something. I'm working on that right now. Still working. See if I can come up with it. Yeah, maybe. working, guys. Still working on it. All right. I think I got something. All right. Still working on, but getting closer now. I have a plan here. Much closer. We said Saturday, right?
Yes,
Yes.
by
And
10
we-
p.m.
We said that day was the November what?
Today is
21st.
okay.
21st.
21st. Okay, almost there. I want to make sure this is clear.
So it's number 11, you said, Dr. Wickman?
It is.
Yeah, I think so. On page 534 of your text. So let's talk about one other thing. Uh, this problem is not hard. This homework problem is not hard. So let's talk about some extra points for it. How about, again, color, creativity, and typing? You get 5 extra points. You could get 115 on this one as well. What do you think?
That sounds good.
Okay, that sounds great.
Now, if you don't hand it in, if it's late, the most you can get is 90. How's that?
Awesome.
Yes.
And this counts 10% of your grade. Um, Okay, so let's be sure that makes sense, and I'm done. It says here, good evening, students. As we discussed this night, your important homework assignment is number 11 on page 54 of your text. This assignment will count as 10% of your total grade, period. We agreed that you would have this completed and sent to me at Carenswood by 10 p.m. on Saturday. If you submit this to me late, the highest grade will be 90. If you have any questions, I encourage you to contact Study Buddy. Please do your best. As this homework. Yeah, that's what we'll call it, homework. Okay, so I'm going to send this out. Hopefully you guys will look at it and say that this is what I understand and that you can get it. So I sent it out. If you guys can give me an amen to that, that would be good. So let me know right now. Anybody's got it.
Yep.
I have it.
Does it make sense?
Yes, it does.
Yes, sir. Everything. We have it here.
I like to do it like this because that means everybody is clear on the homework. Everybody knows what's expected. You guys help build the homework problem. You guys see it, and then you determine the date. So I feel like it's the best way to go. Now, we're going to go to page 8.5. Can someone get me there? What page is that?
547.
And thank you. By the way, not only one, but 2 students and a half helped me with this selection to make this a kind of a good problem. Okay, now, I'm thinking that you still cannot see the book. Is that right?
No, sir.
You can't see it. Okay. How about now?
Yes. I can see it.
Okay, so number 1 problem says consider this, and they want to know the domain. Well, you know the rules are x cannot be 3, because if you have 3 in the denominator, you get 0, and 0 is undefined in the denominator. So it's every number but 3. They show you the answer 2 ways. They use set builder notation, all x such as x is not equal to 3, or they use the interval notation. Either one is good. I think I like the interval better, but for test purposes, if you write x is not 3, I'm happy with that. I'm not going to get you on little nitnat stuff. But if you put x can't be 4, then that would be wrong. All right, so number 2, this gives a list of things. And you know x cannot be 0, so 1's easy. The 1 over x squared is easy. Number x squared plus x minus 2, you got to factor it. That becomes x plus 2 and x minus 1. And therefore, x cannot equal -2. That's in the third one down. And it cannot equal 1 as well. Again, the goal is, and you guys know, you cannot have, again, a 0 in the denominator. Any questions about that? Last one, x cannot equal -1.
No, sir.
Now, asymptotes. Asymptotes are lines of symmetry. Now, look. People make such a big deal. These are just so simple. It's so look. Determine the vertical asymptote. So let's look at 2x minus 11 over x plus 2x minus 8. So we have to factor the x plus 2x minus 8 in A. And that'll tell us what the zeros are. And that's going to be, well, we can just do that ourselves. Straight to Swift. Say, I think it was x squared plus 2x minus 8. That factors to x here, x here. Two numbers multiplied together have to equal -8. So it's going to be a +4 and a -2. So the denominator cannot equal 2 because that gives you 0 or -4. So if it's 2 and -4, this is what those are your zeros. That means on the x, so we said what, 2 and -4? We'll just say that anyway.
Yeah, yes.
So if it cannot equal this, then we're going to draw a line straight through this. A line straight through this, because x cannot equal those points. So these are your lines of symmetry, because x can never be 2 and it can never equal -4. So this position here, let's say, Maria left it. Let's say this is a 3 here. This is 2, 3. Well, it cannot equal 2, 3 because the 2 part makes it 0 in the denominator. So this whole line cannot be in the solution. So that's how come they get this then. That's how come they say for A, let's go to the next page. Click on that to get there. And they're going to show you these graphs, but I'm only going into detail on this one. If we get there. So look to the left. There's your graph, -4 and -2. You can graph this using your calculator. Let me assure you, it's not hard. You just put it in, 2x minus 11. I'm going to do this one. I'm going to work this one to death with you guys. So I have 2x minus 11 over x squared plus 2x minus 8. Why I'm going to do this? Because this is what the test one looks like. Exactly. Almost. So we just put this in our calculator, and you're going to get the graph, and you'll see the zeros. So we'll just do that. So I want you to feel good. I want you guys to feel comfortable in this test, especially the final, because you guys are going to be fine. You can turn this thing on. There, y equals. Hear that. So we're going to have, of course, that's f of x. We're going to put a parenthesis here. So we have some complexity here. 2x minus 11 is going to be on top. Parenthesis. 2x minus 11 on the top, divided by, open parentheses again, x squared plus 2x minus 8. Or close the parentheses. So come on, close. So now you have everything the problem shows. So we just graph it. And it should look just like what we were talking about. And you can see that the zeros look like 2 and -4. If you weren't sure about that, either you go to second table and you find out what the zeros are. So notice it says 2 has an error. That means there can be nothing. Why? Because it's undefined. So that is your 0, 2 error. Now we know -4 is 1 as well. So we go back up now to -4, -2, -3. There's -4, another error because it's undefined. The errors are undefined. I mean, so you can't fail this. I mean, it's just, so anyway, told you I was going to work this one to death. So that's that one. to the next page. I'll turn my thing to vibrate so it doesn't make much noise. Now, horizontal asymptotes. Horizontal asymptotes are, again, horizontal lines. Now, there's only 3 ways to get them, and you guys have that on your test. Or should have, if you didn't, or you will. And that is if the exponents of the numerator and the denominator match. Look at this. You see? Well, let's get to the, what is it? The thing of the book tells you. Doesn't tell you. Not here, but look. Look at number 4. It says you have negative 7x to the 4th and so on, and then 11x to the 4th. Notice that the degree of the numerator matches the degree of the denominator. Therefore, the horizontal line of the asymptote, or line of symmetry, is the numerator over the denominator leading coefficient. So it's negative 7 over 11. Which I don't even think it shows you. It's just that simple. Now look at this one. Notice the numerator in example 5, the exponent for 2x is a 1. If the numerator is smaller than the denominator, then the x-axis is the line. So let's take a look. The x-axis is the line of symmetry. Always. Every time. So again, you're looking for the numerator. Here, now they give you the rules. Jeez. When the degree of the numerator of the rational is less than the degree of the denominator, the horizontal asymptote is the x. So that's that one. If the degree of the numerator, again, here's number 6, if they're the same, so it's 2 over 1, that's 2. They show it to you, boom, that's 2. Now, the other one is when the degree of the numerator is greater than the denominator, there is none. So it just goes all over the place. So this little box is important, but for the test purposes, you need to really focus on, I mean, in reality, it used to be the second bullet. But on the test, it's going to be the first bullet this time. If they're the same, it's the leading coefficient. And that's what they're doing here at 6. Now, an oblique asymptote. What that means, it's a slant asymptote. And you have to calculate one of them, and it's weird. All you got to do is take the numerator divided by the denominator using synthetic division. So the numerator is going to have a 2, a negative 3, and a negative 1. You're going to divide it by 2 because that's what makes it 0. So let's see him do that. Now here's the trick part of it. So look, they don't even use synthetic division. They should, but anyway, they use x minus 2, so you can do that. And notice when they work it out, 2x times x is 2x squared, and so on. They end up with a remainder of 1. You don't consider the remainder of 1. You only consider what you get for the division and forget the remainder. That's in every case. So the line is 2x plus 1. Well, that's the line diagonal 2x plus 1. It means this graph will never cross that. It'll be 2x plus 1 every time. How'd you get it? This is the equation right here, 2x squared minus 3x minus 1. You divide it by the denominator. You're going to get a remainder almost all the time. And the answer is the equation of the line, 2x plus 1. Well, Dr. Wick, how do you graph it? We use a T-chart. 2x plus 1. 2x plus 1 equals y. How do you do that? Well, we know that. Simple. So let's do this. Do this first. We'll do another way too, but if you have 2x plus 1 as your equation equals y, or f of x. If you put 0 in for x, you're going to get y as 1. If you put 2 in for x, you're going to get y is 5. And so on. And so you just start graphing those points. So 0, 1 is here. 2, 5 is here. Let's do a negative number. -2. That's going to give you -2 is over here. And -2 gives you -4 plus -3. -2, -3, boom. You can see the line like this. Now, if you don't like that, you don't want to do it that way, you put it in the calculator. That's what I'm doing anyway. So go there, calculator. Y equals 2x plus 1. That's what we said. So we're going to go to y equals, I got to turn our calculator on. I got a second quick get out of this. Clear that. 2x plus 1. And just hit graph. There's your line. It's that same one that looks like in the book. Oh, let's do this other thing then. Let's do one more step. Let's just work this one to death one more time. We're going to do y equals again. We're going to graph the equation. Can somebody read me the whole equation? What was the numerator? Can somebody read that to me?
2x squared -3x
2x squared. Okay.
subtract 3x minus 3x minus 1.
3x minus 1. And divided by?
X minus 2.
These are parentheses. X, thank you, minus 2, close parentheses. And we'll just graph it and see what happens. Now notice the red is going to be the graph of this because we have red. The blue is the oblique or slant asymptote. Let's just see. Ooh, there you go. Gosh, perfect. Remember, it doesn't cross the blue in any case. Anyway, we did this. Killed it. Problem's good. Now that should be the end of this. I don't think we're gonna need to do any more. And those are, we got the vertical, those are the zeros, the horizontal, and then the oblique. Let's see. So they want you to do it again. We're not going to waste time. Defining the zeros. Again, they they factor through 3x minus 2 and x plus 3, so -3 and a positive 2/3. We can take a look at it. It looks like, but it's just a repeat of what we've done. And there they show them. Graph number 9 is going to be the same way. Find the intercepts. That whatever makes the denominator 0. That's going to be your vertical lines of symmetry. And there they are. You can see them, -3 and 2. The horizontal line, notice it's x squared over x squared, so it's 1 over 1, so that's 1. I mean, it just gets to be so simple after a while. It's the oblique for this one. They just give you another example here. You just got to divide it 2x cubed divided by x squared plus 1, and you get this thing here, y equals 2x. All right, I think we're going to move on now to 8.6. I don't think we're going to need many more of these. These are the same. What page is 8.6 on? Does anyone have that?
8.6 is page 564.
Okay, before we go there, let me reinforce one more time with example 10. You said what page 564?
Yes, sir.
Let me reinforce how easy this is for 10. Look at number 10's denominator. If you factor it, you get x plus 1 and x minus 1. So we know negative 1 and 2 are the vertical horizontal asymptotes. Now, here is the deal with this, though. Because x minus 2 is on the top and x minus 2 is on the bottom, you get a donut. You get a donut hole because they cancel. So the only one they really have is x minus 1 because they cancel. The numerator and the denominator cancel. So you only have one line of but you have to remember the denominator still cannot be 2. So you just put a 0 there because it's that. So now, I hope that just explains it. Now the horizontal asymptote, notice that the numerator is 1, the denominator is 2. So it's the x-axis. Boom, there it is. All right, so we're going to go to, I just wanted to end with that because that was one little bit of a caveat that when you cancel them, you only have one asymptote and you have zeros there. The one asymptote is x minus 1. The donut hole is the 2. All right, 564. Okay. Polynomial inequalities. It's the same thing you've been working, except for this time, we have to find the zeros. So I'm going to focus hard on example 1. And they won't get any more complicated, really, not really. And you'll see that we have is less than 0. It's again, x squared minus 4x minus 5, excuse me, is greater than 0. So let's do this. So in this particular problem, you have x squared minus 4x minus 5. And we know it's supposed to be greater than 0, but we'll set up as equal to. So so we've got to factor this. When we factor it, we get x, a minus 5, and a plus 1. So at the point of 5 and negative 1, we have our zeros. Now, notice that let's think one-dimensionally now. Everything to the left of negative 1 is zone 1. Everything in the middle will be zone 2. Everything to the right is zone 3. Now, notice that in between there are numbers, so we can test a number. We know between negative 1 and 5 we have a 0. We can test 0. We know that technically there's a 6 here, so we're going to test 6. And negative 1, we're going to test negative 2. So if we put negative 2 into the equation, that's the original equation, you get, if we put 2 in there, negative 2, we get 4 plus 8 minus 5. That's 12 minus 5, and that gives us 7. Is that greater than 0? Yes. So all this stuff works here. This is a go. Let's put 0 in now. So we have 0. This is f of negative 2. This is f of 0. So if you put 0 in, you get 0 squared minus 0 minus 5. Is negative 5 greater than 0? No, it's less than. So this is a no-go. Or this would be yes. So now let's try 6. F of 6. So if you put 6 in there, you get 36 minus 24 minus 5. And that equals, well, 7. So this is positive. So the answers are all this stuff this direction, all this stuff this direction, and this is a no-go right here. So now let's go back to the book. So all you're doing is finding the points. Now, they show the graph, but look below it. This is how we're thinking one-dimensionally. This is two-dimensional. One dimension going left and right. These are our zones, -1 to the left, -1 to 5, and -5 to the left. So they kind of break them down. They don't show them as good as I know. They're going to give you test points. They're going to create a little table. And they're going to come up with the test points. You have to use your own brain to do it. But always include 0 if you can, and always use the smallest numbers that you can. So they -5 or 2. They did that. They did the 0, and they did 7 instead of 6. I did 6. So their blue was yes, it worked. The red was no, it didn't work, and blue was positive. So the solutions are, as you can see there, there's nothing different then. So now look at the solution set. It shows it. -1 to negative infinity and 5 positive infinity. Now the only difference between number 1 and number 2 is look, they have an equal sign. So instead of using parentheses for the solution, they're going to use brackets. Same thing. Look at, they just use brackets. There's a bracket, -4. So again, their solution was -4 to negative infinity. That's a bracket. And then 2 to infinity. Now, they don't show the answer here. Oh, wait a second, they do. The question was, in this case, the negative is what you're looking for. My bad. They want it to be less than or equal to 0. The only one that is less than or equal to 0 is this red one. So that's the only solution you have, and it's a bracket. You got to remember what they're looking for, greater than 0 or less than 0, or whatever they're asking for. So again, once you find the zeros, you just test points in between. You come up with them out of your own brain. And always pick 0 if you can. And always pick the lowest number if you can. So number 3, this is the last one I'm going to do. These are the same. They factor out an x. So they get x, open parentheses, x squared minus 1. They factor that again to x plus 1, x minus 1. Now, the only thing they can do is create 3 test points, which means you have 4 areas to test. -1, 0, 1, and to the right and the left, and all this in between. So they got to come up with numbers. So to the left of -1, I'd try -2. To the right of 1, I'd try 2. I do a -1/2 on the left is 0 and a positive 1/2 to the right is 0. So those are my 4 test points. Let's see what they come up with. And they do the same thing. They just use decimals. Okay, so then they come with negative numbers, positive, negative numbers, and positive numbers. They want positive numbers. Or do they want negative? Let's see. They want x is greater than 0. They want greater than 0. So what makes it greater than 0? -1 to 0 because it's blue, and 1 to infinity. And notice again that because number 3 was a greater than sign, they used parentheses. So you'll see your solution has in intervaltation parentheses, no brackets, and there's your set builder. All right, next chapter. We're going to go to 9.1. Can somebody give me that page?
Yes, it's page 593.
593. Now, if there's any of the stuff that you don't get or don't quite understand, I mean, what I shared with you tonight is what you'll be tested on. And if you know that, you're in good shape. If you see something else there that you don't like and don't want and but would like to know about it that you don't know about, just see me and I'll gladly go over it with you, but you won't be tested. Now, this is important. These are composition functions. They have a little circle, so your brain has to change gears. So the f function in example 1 is 2x minus 5. The g function is x squared minus 3x plus 8. So they want you to take f times g, or f of g, correction, not times, f of g. That means f is your main function. That means 2x minus 5 is your function. And you plug g into wherever the x is. It looks like this. Look at A. Remember, f function was 2x minus 5. The g function is x squared minus 3x plus 8. They want the f to be the main equation. So you have to put g into the x position of the f equation. And that's what they do. So you have 2 times x squared minus 3x plus 8. And then you have minus 5. And then you work it out. And you get 2x squared minus 6x plus 11. Now, the only thing that they can do different is they can switch the order, and they can say f of x is a 2. So that means after you work it all out, you're going to put 2 in for x, and you're going to get a number. Now, is there a question on this? This is f of g. They ask you also to do f of g with 7 in there. So you're going to do the same thing, but you're going to plug in 7. So let's go to the next page. You don't plug in the 7 until the end. Although you could, but it just would be harder. It would not make sense. So let's see. Here they do 7. So they have f of g, like they show there, means f is the main function, and they plug 7 into it. And they plug it in. 7 squared minus, I mean, they do it the other way. The one I said I wouldn't do it that way. I would put 7 in the end equation, but they put 7 in here. 7 squared, they show it to you. That's 36. Then they take negative 26 times 7. Wherever that is, they don't show that. And then plus 48. They don't show it like that. I guess they just probably should just make up my own. So the way they're teaching you to do it is you find the f function and you simply plug in the 7 to it. Then you plug in the other number to the g function. Then you work them together. Not explained very well. Let's look further down. If you recall, the way I said to do it, you found 2x squared minus 6x plus 11. Going all the way back to the previous problem on the previous page, you would get this as your equation. Right here, in the middle of the page, 2x squared minus 6 plus 11. I then said plug in 7 for x squared, the easiest way to do this. So then you have 2 times 7 squared, minus 6 times 7 is 42, plus 11, you get 67. And that's the answer you need, 67. That's the correct answer. Now they do g of f, which means they do a different thing. That means g is the main function. So if g is the main function, let me explain it. They don't show it very well here. Let's do number 2. Let's go on to number 2. Find f of g. So f is the square root of x. G is x minus 3. If f is the main function, then you have the square root of x minus 3 because x minus 3 goes inside it. You plug that in for x. Now, if I wrote this problem, let me do this one for you, and then have you do it. F of x equals square root of x, and g of x equals x minus 3. F of g equals the square root of x minus 3, and f of g of x, let's say, what do I want x equal there? Let's say, okay, here's what we're going to do. I want you to see how easy this is. We're doing the same problem they have. F of x equals square root of x. G of x equals x minus 3. I want you to find f of g of 7. Now, how would you do that? Well, f of g means f is the main function. You put square root, and then you got to put the g inside it wherever the x is. So x is technically right here. But we have to plug this in for the x. So now we have x minus 3. Now we've done that part. Now we got to plug this in for the x. So f of g of 7 equals the square root of 7 minus 3. And what does that then equal? Somebody following correctly?
4.
4.
2 is correct. You're right, 2. How'd you get 2?
We said 4, but it's squared, so it's 2. 2
Square rooted.
times 2 makes, yes.
Yeah, so you meant 2, I think. I mean, I think what you were all answering the question. You were saying the square root of 4, and then I said, yeah, you're right. And then I know that you meant to go to 2 from there. Yeah, everybody did this. That's right. You just were thinking in the logical process. You're right. Does that make sense to you guys?
Yes.
So that's what they're trying to teach you to do. Now, on the test, it's going to be a more complicated problem. Not only in the sense that it's going to be longer. Let's see what we can come up with here. Let's go to number traits. We have to do one other one besides this too. Okay, now, now they simply want you to find the domain. Well, you know, f of x cannot have a 2, the g of x cannot have a 0. And they want you to calculate f of g. F of g, that means you have the main function is 1 over x minus 2 because it came first. F. You got to plug in the g of x function where there's x. So you have 1 over 5x minus 2. Second. It's Dr. Wickman. Hello? So you can see that in this particular case, that's what you substitute there. Now the question is, how do you do it from there? You substituted, you have 1 over 5 over x minus 2. And students seem to have a hard time understanding, well, I don't get it how to do from there. Well, let's do it. Let's make it easy. Let's show you again that this is not hard. So after we substituted in, according to the guidance, we had 1 over 5 over x, because that was your x, minus 2. Now, in order to do this, we have to have a common denominator, and that's going to be x. So if we multiply this by an x and this by an x, we have a common denominator. That's 1. So now you have 1 over 5 minus 2x. Now, does everybody see how I got to that point?
Yes.
Now look at the trick here. Let's stop for 1 second, because students still seem confused sometimes. So at this stage, we got the 2 to be an x in the denominator. But we multiplied the top of that equation by x. So we ended up with 1 over 5 minus 2x over x. But we still have an x in the denominator. So let's go back. Oops. Again, we're going to take it step by step again. I want to make sure you understand it. So you have 1 over 5 over x minus 2. We said we had to get a common denominator. We said we had 5x minus 2x all over x, which gives us now 1 over 5 minus 2x all over x, because the common denominator goes together. Now, notice, with this problem, we still have an x in the denominator. So let's multiply by the reciprocal. Or let's multiply the bottom by x. And whatever you do to the bottom, you can do to the top. That means these cancel. You're left with 1 times x in the numerator and 5 minus 2x in the denominator, which is x over 5 minus 2x. That's all you did. Why? Because we had an x in the denominator right here. So the answer is x over 5 minus 2x. And you know how to solve that one. X can't give you what? X can't be a positive 2/5. You can take this number, put it on this, and change the sign. So let's see what the book says. So we have x over 5 minus 2x. And that's that one. Now, this next thing here has nothing to do with that one, the top one. The g of f means the g1 comes first. That means you have 5 over, and then you put in the denominator 1 minus x minus 2. Multiply the top of this by x minus 2. Well, let me do this one also for you so you can see how this was even simpler. You have 5 over 1 x minus 2. One over 5 over x minus 2. Is that how it's shown? Let me go back.
I thought it was 5 over 1. I'm not sure.
No. Let's see. Let's cancel. Go back and make sure we're exactly right. Because I want to teach you a problem that doesn't coincide. You have 5 over 1 over x. Yeah, you're right. You are right. Weird. 1 over x minus 2. I don't know why I didn't have that right. Yeah, you're right. Gosh. All right, so let's go. So you have 5 over 1 over x minus 2. Now, in order to get the denominator to be 1, I'm going to multiply by the reciprocal. Just x minus 2 over 1. Obviously, the bottom is going to then be 1. But whatever you do at the bottom, you got to do the top. So you got to multiply the top by x minus 2, which is going to give you 5 times x minus 2 in the numerator. That's all they're doing. This is so simple. Remember, whatever you do at the bottom, you got to do the top. You know, if you have 3 over 2, which is 3 halves, multiply the top by 2, multiply the bottom by 2, you get 6 over 4, and it's always going to be the same. 3 over 2. So that's the rule. Whatever you do bottom, you got to do the top. They just make it look complicated. And that's what they get, 5 times x minus 2. I didn't multiply it out. Now the 0 is you can't have x be a 2, because that's the domain issue. And we know that, because look at the problem. X cannot equal 2, and x cannot equal 0. But 0 won't play into it. It shows it right there. Everything but 0, and everything but negative 2. You always have to be worried about the domain. And they show the work. Go on to another one. Now, this is, I have to show you this, and this will be the last thing because this is on the test. I almost want to make up my own for you. But let's see what they come up with. Let me do my own. Let me do my own because it's more related to the test and it's easier. Although these are the same, going to be the same sort of things. But let me give you this. And again, I believe that this time I can make it even better for you. So let's say we have, this is our equation. The square root of x plus 3. And they want this to make this into a composition function. So we see the first part is a square root. So we're going to call this f equals the square root of x. Then the g function is going to be x plus 3. Because it's whatever's inside. So we can say, oh, to recompose this, we can say f of g. And that's going to equal the square root of x, because that's the f first. And we plug this in for the x, which gives you now the square root of x plus 3. Because this counts for your x. Does that make sense?
Yes, we have already done this on the test.
Yes, I just want to be sure. Okay, well, that's it for today. Just wanted to make sure that this is, makes sense again. The book doesn't give you the same one, but this will also be in the final, so we're going to check with that. So the next thing we do is inverse and exponential, and that's 9.2. Let me do one more thing, and I got into it a lot, and sorry, I just want to be sure everybody's clear. the stuff looks complicated, but I don't want you to feel like it is. So let me just again check to see anybody came in that I didn't give credit for, because I certainly want to give you credit for being here. Let me look at my sheets. I got it over here. Let me just check. Did Yulissa Alvarado ever make it in? No, Yulissa? How about Tamara?
Yes, I'm here.
Tamara's here?
Yes.
Alicia Marino shows up. So Alicia, you're here, but no Tamara, right?
Yeah.
Oh yeah,
Tam's here.
Tamara. Yeah, you're here.
Yeah.
Okay. So, but no Yulissa Alvarado, Maria Alvarado. Let's say, yeah, I got Maria now. All right, let me go on. I got you, Tamara. You're in.
Okay, thank you.
Mariella, Barrielos, are you here? Nope. We're getting a lot of feedback. Let's see. How about Viridiana? Did you make it in?
Yes, sir.
You never
Yes,
knew.
sir.
My
No.
God. Okay. And Daniel Ramos and anybody else? Got everybody else? I got marked in. Anybody else miss? All right. Thank you guys for your patience. I really appreciate you all. And the homework problem is 10%. So don't forget to do that.
Thank
Yes,
you.
thank you.
Thank you guys. I
Thank you.
appreciate
Thank you, Dr.
all.
Rickman. Good
Thank
night.
you so much. Appreciate your
Good
patience.
night.
Good night.
Good night.